Hey guys, welcome back to school. So what I'm going to do is show you a couple examples on how you can identify a function from something that's not a function. So what I like to do is start out by just showing a mapping because it's a good graphical organizer to illustrate it. So let's go over the actual definition of a function. So basically each element of the domain has to be paired with exactly one element of the range. So exactly one is the key here. You got to remember your domain, those are your x values, and the range, those are your y values. Okay, so you look at a mapping. A mapping is just showing you which x values are paired up with which y values. So if we look at this first domain value, which is -1, it is paired up with two members of the range. So that's going to go against the actual definition of a function. So since -1 is paired up with 4 and 5, this mapping would not represent a function. Okay, so that -1 could only be paired with one member of the range. Alright, so since we see two arrows emanating out of the domain, it's a no. Whereas over here, for example 2, you see the 5 is paired up with only 4, 2 is paired up with 1, 0 is paired up with -2, and -3 is paired up with 2, then -2 as well. So every x value is only paired up with one y value. So that's okay. That's following our definition of a function. So this one would be yes. Okay. So we'll move on to the next example. So here we're looking at a relation. So relation is just a set of order pairs. So again, it's going up with each member of the domain. The x values has to be paired up with exactly one member of the range. So exactly one is the key. So when you're looking at a relation, what I like to do is I like to try and spot multiple x values. So if we start with example 2 first, I have 6 for an x value. And what I want to do is go and take a look at the other x values and see if I have another 6, which we do. So you have two 6s there. So if you were going to draw an actual mapping, the 6 would be paired up with the -1 and the 6 would be paired up with the 5. So it's going to go against our definition of a function. So this one would be no. And if you take a look at this example right here, every x value is unique. So there's no repeats on the x values. So that means that each element of the domain is paired up with exactly one element of the range. So this one would be okay. So this is a yes. So really the key here is to look for the repeats, the repetitive x values. Okay, and the question is, do they go to a different y value, which is true here. 6 goes to -1 and 5. Alright, the table is simple, similar to looking at a relation. So you just want to look at repeat x values. So if you look at example 2, we look at this first. In example 2, do I have any repeat x values? The answer is yes. That 5, it's pairing up with -3. It's also pairing up with 2. So right there I can say that this is not a function. Whereas in example number 1, every value of the domain, the 4, the -1, the 0, the 1, the 9, those are all different x values. I don't have any repeats like I do over here. Okay, so this one would be yes. And then over here, okay, so if you have a graph, you can use this thing called the vertical line test. So what you do is you draw a bunch of vertical lines through the graph. And the vertical line test says that if these vertical lines, so if you look at example 1, touch the graph in more than one spot, it's not a function. So you got a vertical line hitting once, twice, another vertical line hitting twice. Same thing over here. So number 1 would not be a function. Okay. Whereas in example number 2, just one hit here, just one hit here, another hit there, another hit there. So on example number 2, the vertical lines only pass through the graph once, so that's okay. So this would be yes. And that's basically it. So hopefully that kind of explains that a little bit more. And we'll see you guys next time.